Thank you, everybody. That is great. My hair look okay? Got a little spray. Give me a little spray.
This is the story of an apocalypse avoided.
You know, you're not allowed to use hairspray anymore because it affects the ozone. You know that, right?
In the 1980s, we realized we were destroying our atmosphere. We faced a future in which the sun's rays would be so strong, we'd be forced to hide from daylight.
To the luck of the human race.
But for the first time in history, every nation on Earth came together and solved the planetary problem. Today, as climate change feels like an impossible challenge, the forgotten story of the hole in the ozone layer and how we managed to fix it is a tale worth remembering. Because we got it right.
I said, wait a minute. So if I take hairspray, and if I spray it in my apartment, which is all sealed, and you're telling me that affects the ozone layer? Yes. I say, no way, folks, no way.
Our story begins with Thomas Midgley Jr., a brilliant chemist who unwittingly developed a chemical that would threaten all life on Earth. But at the time, he was just trying to make things better. In the 1920s, chemistry was finding solutions to all kinds of problems. The first refrigerators were simple ice boxes. The ice had to be delivered every week.
I remember the iceman would come with a big thing of ice. It was great because he'd chip off some ice so that he'd give it to the kid so we could suck on ice. Wow.
Then came early mechanical refrigerators.
My parents thought they were great.
But they used dangerous refrigerant gases. A leak could kill you.
If you wanted to sell a refrigerator, you didn't want to sell it to somebody if it would explode or if it leaked and would kill everybody in the house. So you wanted something that was non-toxic, it wasn't explosive, and it worked well. Thomas Midgley was assigned to actually work on this problem.
Chemistry, alchemy, magic.
Midgley developed a group of man-made chemicals called chlorofluorocarbons, brand name Freon, that could be used as refrigerants and were totally harmless.
There's a famous story of Thomas Midgley going to American Chemical Society meeting, and he actually inhaled some of this CFC, and then he blew out a candle. A really kind of a dramatic demonstration of the non-flammability and non-toxicity of this particular gas.
Non-irritating to nose, throat, and lungs. As for the non-flammable quality of Freon, just look. Out go the candles, 1, 2, 3.
Midgley had no idea how devastating these simple chemicals would turn out to be. In fact, he's probably the most unfortunate inventor in history. He also created leaded petrol that poisoned millions. And when he contracted polio, he designed a system of pulleys to lift himself out of bed, but he was later found dead, strangled by the ropes of his contraption. At first, though, Midgley's CFC started out as a good idea.
Better things for better living through chemistry.
They could be used to produce safe refrigerators.
Ladies and gentlemen,
And everybody wanted one.
here they are.
But it didn't stop there. CFCs were so versatile, they had all sorts of uses.
In World War II, they needed a propellant for bug sprays that was non-flammable for use in tents or whatever. They used CFCs as propellants. Then after that, the use of CFCs in personal care products as propellants rapidly increased.
Raid hunts them down like radar, attacks them as they crawl.
Bug sprays, hairsprays, deodorants, perfumes.
The air you breathe is changed several times a minute without a window being open.
In the 1950s, it was automobile and space air conditioning in homes.
We found the CFCs were good as foam-blowing agents, a solvent for cleaning chips, for supercomputers.
They used to use it in meter-dose inhalers for asthmatics. So these are really wonderful gases.
The wonder chemicals of the 20th century.
Give your home a good, healthy spray.
Meanwhile, half a world away, an ingenious British scientist was thinking about the atmosphere. Jim Lovelock had formulated the Gaia theory of the Earth as a self-regulating system. In the 1960s, he thought that the air around his country home appeared to be polluted.
We had a house in a wonderful village about a mile from the border of Dorset. In the summer, there was a dense haze filled the air whenever the wind was coming from Europe. And it looked and smelt to me like Los Angeles smog.
Boulevard, eastbound on the 10, all the way from 4th Street in Santa Monica to the 5, you're under 20 miles an hour, northbound on the 101.
I talked to people at the Met Office, and they said, oh, nonsense, no, it couldn't possibly be smog. It couldn't have smog in England, in a countryside district like that.
Jim had invented a highly sensitive instrument for detecting tiny quantities of chemicals. So he put it to use, looking for signs of man-made gases in the air.
And I thought, what compound is unequivocally human? No natural source whatever. What better than the CFCs?
Jim found CFCs in winds coming from the populated areas of Europe. But he also found them in air from the empty Atlantic. He wondered how far CFCs might be spreading.
To find out would give me an excuse to go on one of the ships that goes down to Antarctica and back. I like ships, I like going for rides on them. So off I went. I loved every moment of it.
To his surprise, he found CFCs in every air sample he collected. These hardy chemicals were drifting around the entire planet. He published his findings in the science journal Nature, but merely as a point of scientific interest. He didn't see the spread of CFCs as a danger.
I was not in the least worried because the amount there was at that time was so trivial. I was measuring parts per trillion. That led me, in my Nature paper, to state that these compounds represent no conceivable hazard, which was a great boo-boo, as it turned out.
In 1973, not long after Lovelock's paper was published, Mario Molina joined the chemistry lab at the University of California, Irvine, as a young researcher.
That's where I met my colleague and very good friend for many years, Sherwood Rowland. Sherry, as we call him.
Sherry showed his new recruit the Lovelock research and suggested he investigate where these wandering CFCs might end up.
Maybe nothing happens, but maybe it's something to worry about.
Between 10 and 25 miles above the Earth, in what's called the stratosphere, is a belt of
ozone. Ozone is a gas. The ozone layer is
just here, a vital part of the Earth's atmosphere.
Essential to life on Earth because it screens out dangerous ultraviolet rays from the sun.
Mario worked out that CFCs were so unreactive, they survived in the atmosphere for decades.
Essentially, nothing will happen to them that will remove them from the environment until they reach relatively high altitudes. Everything reacts at sufficiently high altitudes.
He predicted that when the CFCs were broken apart by radiation from the sun, the chlorine that was released could destroy the planet's protective ozone layer at a terrifying rate.
If If this happens, the Earth's shield against harmful radiation would be weakened. Dangerous extra radiation would penetrate to the surfaces of the Earth.
Those rays can cause cancer.
Actually, my first reaction was that there should be some mistake.
I remember I had an almost emergency meeting with Sherry, just explaining to him, we have this potentially huge problem. Look, here is what might happen. And he said, wow, well, we better look at it.
Sherry, who is my husband, a very good husband, I might add, came home one night, and I was in bed reading, and I said, you know, how's the work going? And he said, it's going really well. The only trouble is, I think it's the end of the world.
Life on Earth spent the first 3 billion years hiding in the sea. Only when a protective layer of ozone gas had formed around the planet were creatures that ventured onto land safe from the sun's ultraviolet radiation. Mario Molina's calculations had shown that CFCs could be destroying so much ozone, we faced an epidemic of skin cancer, the collapse of agriculture, and the destruction of entire ecosystems. In June 1974, Sherry Rowland and Mario Molina published their findings. But nobody noticed.
It didn't make any noise because you were talking about invisible gases reaching an invisible layer, this holding invisible rays. Anyhow, nothing happened. They say, oh, you must be exaggerating. How can these very stable industrial compounds do something that will be a global issue? We think you're probably exaggerating. And we were worried, wow, society is just not interested in this. That's when we realized we had to be much more proactive, of course.
There must be a better way.
You might just believe that the next major threat to the world will come from
Mario and Sherry began to speak out.
To avoid these hazards, man cannot continue his ever-increasing use of these chemicals. Instead, we must rapidly reduce in the future the amounts of these materials released into the atmosphere.
Stepping outside of the traditionally neutral world of science, Sherry argued that the production of CFCs for aerosol sprays, the largest use of the chemical, should be banned immediately.
Many faculty people, universities nationwide, really objected to the fact that Sherry was making recommendations about what industry should do. They felt that was absolutely improper. As a result of that, suddenly no more invitations to give seminars in chemistry departments anywhere in the country. No more students sent or postdoctorals for about 10 years. And that really did hurt his feelings. But what are you going to do? You stop? No.
We felt a great responsibility to actually warn society that something could happen if you were to continue producing these compounds.
Major chemical producers such as DuPont, Allied and Union Carbide were producing nearly 900,000 tons of CFCs each year. Sherry and Mario were threatening an $8 billion industry, while America was in economic recession. The chemical companies began to fight back.
Regulation is premature and it's absolutely wrong. It has the potential effect of destroying a perfectly good and useful product without any scientific support.
At scientific meetings, sherry came under fire from industry.
At the question and answer period, they would stand up and wave papers, and usually the question always would start with, have you ever thought of, and how dare you scare the world? And you're destroying an industry, you're practically destroying the economy of the United States. It was that kind of thing that was not pleasant, shall we say that.
In 1975, the DuPont Chemical Company placed notices in newspapers stating that as soon as there was reputable evidence that CFCs were a health hazard, they would be prepared to stop production of the offending compounds.
Man-made chemical gases could cause a health catastrophe here.
The press picked up on the debate. Feisty scientists battling powerful chemical companies was the perfect story for an America fresh from the hippie era of mass protest. The culture of rebellion produced a generation that would tackle the CFC problem head-on, including Steven Anderson.
Imagine this, I'm 20 years old, I've just driven a Volkswagen from Utah to Berkeley, California. It's the first day of classes, I buy all my books, I'm sitting eating a sandwich, and then a tear gas canister landed at my feet. It blinded me. I could not see anything. It was this terrible nausea and blindness. So I stood up and ran into a tree and knocked myself out.
Steve had arrived at the University of California, Berkeley, when it was the epicenter of an international student protest movement.
That was a big wake-up call that you're not just a little student at a university, you're part of a very big deal here.
The governor of California, Ronald Reagan, had been elected promising to clear up what he called the mess at Berkeley.
You created an atmosphere on the campus where no one wants to listen.
You are a liar. Now, don't you talk about political speeches. Don't you make a political speech of that kind.
The protests became mass demonstrations. The public demanded action on civil rights, the Vietnam War, and the environment.
This is one of the nation's best sellers. Up to now, 500,000 copies have been sold.
Rachel Carson's book about the risks of pesticides had shocked the public.
She woke a lot of people up in America to the dangers of pollution, that perhaps not all chemicals were really good for you.
April 1970 saw the first Earth Day. 20 million Americans called for protection of the environment. Shaped by this era, Ronald Reagan, Steve Anderson, and Susan Solomon would all become key figures in our story.
The ozone issue kind of came along at just the right time, when people in America who were already very attuned to environment and pollution learned that the thing that was causing this potential threat to the ozone layer was their use of hairspray and underarm deodorant. They got pretty engaged.
From Television City in Hollywood.
In February 1975, the CFC issue reached its peak when it featured in the most watched show in America, All in the Family.
One of those shows was the controversy where Gloria, the daughter, decided it was socially irresponsible to use hairspray.
Oh yeah, what about spray cans?
What?
Yeah. Here, right here. This is a killer.
Oh, so now my hairspray is a killer.
Yeah, your hairspray, my deodorant, all spray cans. I read that there are gases inside these cans, Gloria, that shoot up into the air and can destroy the ozone.
Then as the show progressed, it became more and more technical information.
What's the ozone?
The ozone is a protective shield that surrounds the Earth that protects us against ultraviolet rays. You know what they can do?
Yeah, they can give you a sunburn.
Sure, when the ozone's there, but when it's all gone, you can get skin cancer, and God knows what it could do to the plants and crops.
When the show ended, there was a national response of people stopping by the hairspray and the deodorant. There was a measurable decline.
You let me have a baby and I'll let you have my hairspray.
The aerosol industry credits that All in the Family show with being their own death knell.
Scientific concern that aerosol sprays damage the Earth's ozone layer has led Oregon to ban the sale of the sprays beginning today.
Oregon is the first to pass such a law, but it probably won't be the last.
The Food and Drug Administration said today it plans to stop the use of fluorocarbons as the propellant in aerosol sprays.
Following the public reaction, the US government banned the use of CFCs in aerosols.
DuPont, the largest producer of fluorocarbons in the world, today called the FDA move astonishing.
But a forthcoming report says that in spite of that ban, the problem is far worse than believed.
When the government phased out use of fluorocarbon propellants in spray cans, it didn't affect similar chemicals widely used as coolants in refrigerators and air conditioners.
As sales of fridges and air conditioners grew, the production of CFCs was soon on the rise again. And now,
together, let us make this a new beginning.
There was a new attitude in the White House. Environmental protection wasn't high on President Reagan's agenda.
We've got environmentalists who wouldn't let you build a house unless it looked like a bird's nest.
Ronald Reagan's record on the environment left a lot to be desired. His appointments at EPA ranged from incompetent to simply pro-industry.
To head the EPA, Reagan opted for Ann Gorsuch. She told Congress that Sherry and Mario's theory was highly controversial and cut the agency's research on it.
I have been and will continue to be dedicated to the President's principles and to the job of environmental protection.
We worked around those people.
Right.
We involved scientists from around the federal government and epidemiologists and skin cancer experts and, put together a fairly compelling case.
Then Steve got lucky.
I think I've always been what I'd call a problem solver.
Lee Thomas was appointed by Reagan to be the new head of the EPA.
I think this truly is an issue that we've got to come to grips with for our children.
And I can remember the day in my office where with staff, people like Stephen Seidel, we were talking about, well, how are we going to do this in terms of a solution? I remember reacting and I said, well, it sounds to me like what we've got is a set of chemicals here that are causing a problem. I think what we need to do is focus on how do we phase them out.
For Lee, the problem required drastic action. A complete ban of all uses of CFCs, and not just in America.
The rest of the world produces more of the chemicals than does the United States.
One of the things I was convinced of is if we were going to have a solution, you couldn't just restrict the U.S. companies or they would fight you tooth and nail.
At the same time, NASA's Bob Watson also recognized that the CFC issue was a planetary problem. Bob's team monitored the health of the ozone layer and provided politicians with predictions from computers modeling the effects of CFCs in the atmosphere.
Slowly but surely, I brought in more scientists from across the world together for one international assessment. The argument was very simple. If you've got a global problem and you need global action, you really need one piece of work that was trusted by all governments of the world.
The evidence against CFCs mounted, and by March 1985, there was international consensus. More than 20 nations signed the Vienna Convention for the Protection of the Ozone Layer. They agreed ozone loss would be disastrous, but they didn't take action to reduce CFCs. The clock was ticking.
Even if those chemicals were outlawed tomorrow, there are already enough of them in the atmosphere to continue doing damage for decades.
What they didn't know in Vienna was that a researcher at the British Antarctic Survey had already spotted that something was amiss in the southern sky.
one of the things that we've used in the 1970s.
Given all the fuss about CFCs, Jonathan Shanklin had examined historic records of Antarctic ozone measurements, dating back to the 1950s.
I started plotting up some of these by hand on a sheet of graph paper. And what we've got are each year's ozone observations from 1957 up to 1984. And up until the mid-70s, you probably couldn't say much was going on. But then after the mid-70s, things start going downhill. And ozone values are getting lower and lower.
The record showed that in the Antarctic spring, half of the ozone layer above the Halley Bay Research Station seemed to disappear.
Here was blinding evidence that something dramatic was happening in an incredibly short period of time. It was really this graph that I took to Joe Farman and sort of plonked it on his desk and said, look, something is going on and we need to explain what.
John's bosses, Joe Farman and Brian Gardner, were stunned by what they saw. Detailed monitoring of the planet's ozone layer was carried out by a state-of-the-art satellite instrument called the Total Ozone Mapping Spectrometer, controlled by NASA's Goddard Space Flight Center. John couldn't understand why NASA hadn't spotted the missing ozone already.
I actually wrote to the guys that were doing the calibrations of satellites, pointing out that our ozone values seemed a bit low, and was this confirmed by the satellite?
Yeah, but you have to realize that here at Goddard, there's 10,000 people who work here. So who do you send the letter to? They'd actually, written to the wrong guy.
With nothing from NASA to suggest they were wrong, Joe, Brian and John published their results in May 1985.
Every October, a hole appears in the ozone layer over the South Pole. And what worries scientists most is
they're still not exactly sure what causes the hole.
The Farman paper landed like a bombshell.
We went back and looked very carefully at the satellite observations, and we realized the way we were processing the data was wrong. If you get what I call strange results, you just reject them. And so when we started to see the ozone loss every September, October in Antarctica, the algorithm we use just discounted all the data. It threw it away.
The paper was a huge shock. We'd been thinking about ozone depletion being something like, 5% of the ozone layer would be lost in maybe about a century. It was only a theory. It was a long time in the future. Gee, does that sound like a phenomenon that we talk about today? But all of a sudden, we had this huge surprise, which no one anticipated, that it wasn't 5% 100 years from now, it was 35% now.
And so people began to move quite quickly. We started showing our satellite data around. I mean, it was really, I think, visually stunning for people to see that it was continental in scale. And in fact, a big amount of ozone was being removed. And that's where you get the term ozone hole. It looks like somebody punched a hole in the ozone layer. After you realize it was continental in scale, but you did not know the cause, you began to really worry, where does it end? I mean, all we could see was that ozone was going down, and it was going down fast. And so where did it end? I got to admit that there was some nights where I was a bit sleepless thinking about that. What had we done?
The key question was why? Why were we seeing such a large loss of ozone? Was it due to volcanic activity in Antarctica? Was it due to these chlorine-containing compounds, or was it just some weird meteorological phenomena? And so it was absolutely crucial that we could go down to Antarctica and actually do experiments that could differentiate between these three theories.
While the scientists did what scientists do, the politicians in Washington were struggling to convince senior officials in Reagan's cabinet that CFCs presented a genuine risk. John Negroponte was the Assistant Secretary of State responsible for environmental issues.
There was a solid group of people in the interagency process in Washington who believed the science, but there were deniers too. There were, if you will, climate deniers, ozone deniers at that time, just like we have them today in Washington. And they were, some of them were in very high places. The Secretary of the Interior, Don Hodel. The science advisor of the president was not convinced, which was a bit surprising.
In one meeting, Hodel suggested that rather than sign up to an international treaty to ban CFCs, Americans should simply learn to wear hats and sunscreen. Someone felt that Hodel's comments should be leaked to lawyer David Doniger. But Dave wasn't at his desk.
I had to get my car fixed.
So they called the repair shop and told him the story. He immediately contacted his friends at the Washington Post and the Wall Street Journal.
I couldn't tell them who my source was, so I said, just call Secretary Hodel and see what he says. So I waited in this auto repair shop. Half an hour later, the reporters called back and said, you're not going to believe this. Donald Hodel is confirming what you said.
The press had a field day.
Hodel became a laughingstock.
Don Hodel's personal protection plan, as he called it, soon disappeared from cabinet meetings. Meanwhile, the chemical industry had started to look ahead. They hinted that they may be able to develop new compounds to replace CFCs. All that was needed now was the president's support for a global treaty to phase out CFCs.
I was Secretary of State for President Reagan. John Negroponte is the one who called it all to my attention, and I paid very close attention to him.
Basically what happened, Mr. Schultz himself, who was a strong believer in this effort, and he was no starry-eyed idealist, he, on very pragmatic and practical grounds, thought it was a good idea to bring these chemicals under control. He personally laid it all out for President Reagan and explained it. I mean, I was not at the conversation, so I don't know the exact words that were exchanged, but the president did not say no.
Reagan, who'd had skin cancer on his nose,
stay out of the sun,
understood the threat from the sun's radiation.
Oh, that's hot.
There were scientists who thought the ozone layer was depleting. There were perfectly respectable people who doubted it. He said to them, well, you have your opinion, I respect that. But you do agree that if it happens, it's a catastrophe. One-way street. So why don't we take out an insurance policy? And that was a good concept. It didn't get people on our side, but it got them off our back.
Mr. Cooper, the reason we've asked you here is to get your opinion on a little movie we've put together about Montreal.
Good city. With the president's backing, the EPA administrator Lee Thomas travelled to Montreal in September 1987 to attempt to negotiate a global phase-out of CFCs.
We are here today because we recognize that urgent action is necessary to prevent destruction of the atmosphere's protective ozone shield.
At the very same time, teams of researchers were in Antarctica and Chile to investigate the cause of the ozone hole.
What we knew was there was an ozone hole in Antarctica and not in the Arctic. Kind of unusual. We knew that it was there in the springtime. So the idea that I had was, well, you know, chemical reactions might be happening on polar stratospheric clouds.
Susan Solomon, a brilliant young chemist, had a hunch that chlorine from CFCs could be gathering on high-altitude clouds that only form in the coldest skies.
Normally, clouds don't form at stratospheric heights. When you fly around in an airplane, you can look down and see clouds. But, you know, if you're high enough and you look up, you know, unless you're in Antarctica, you won't see a cloud above you. What are we doing, a blue or a red?
This is a red.
When you have a cloud and it provides a surface, chemistry changes dramatically, and that's a fantastically interesting phenomenon to me.
Okay, that looks good.
Susan's idea was that cloud particles provided ideal surfaces for chlorine from CFCs to react on and release chlorine gas.
If I remember right, George and I did about 30 seconds.
When sunlight hit this chlorine in spring, the ozone layer was rapidly destroyed. To find out if she was right, scientists in Punta Arenas in Chile prepared to fly research planes directly into the ozone hole.
We took 150 scientists and technicians, pilots, down to Punta Arenas for a 6-week period. The DC-8 was a plane that could only fly at about 40,000 feet. And it would effectively look upwards with the instruments to try and measure ozone. But the key, the truly key plane was the ER-2.
The beauty of the ER-2 was that it could fly up at 20 kilometers right into the middle of where this ozone depletion was supposedly going on.
As soon as the planes landed, the scientists quickly analysed all the data. And that was the eureka moment. Everyone said, we know the answer, basically. Now, one had to be careful. We decided to not tell the negotiators in Montreal what we'd found, because if we'd have been wrong, the negotiators would never, ever have trusted us again. All we have is our credibility. And so while we were almost sure with what we'd found in Antarctica, we wanted to be doubly sure.
Meanwhile, in Montreal, on the 16th of September 1987, with Lee Thomas leading the way, more than 30 countries agreed to cut the use of CFCs by 50% within 12 years and signed the Montreal Protocol, the world's first global treaty to reduce pollution. Two weeks later, NASA released the ozone hole flight data. When the plane had entered the hole and ozone dropped, chlorine levels soared. They'd found the smoking gun. Man-made chemicals were destroying the planet's atmosphere. To make matters worse, ozone losses were soon detected in the north.
What we're dealing with is a problem that extends to the very populated regions of the northern hemisphere.
All eyes turned to the chemical companies. Having fought the idea of a ban for 14 years, DuPont finally announced they would end production of CFCs, but they didn't say when. First, the world needed to work out how to live without Thomas Midgley's wonder chemical. Back at the EPA, the colossal task of finding ways products could be manufactured without CFCs was handed to Stephen Anderson.
So this was the most miserable job someone could get. What's hard to believe, looking back, is how many things we had to change. There were medical applications, weapons applications, rocket manufacture. There were foam-blowing agents for cushions in chairs, for the dash, for the doors. everything imaginable, from a refrigerator to the space capsules. 100 chemicals, 240 sectors.
Next up, the developing nations. They couldn't afford the new CFC-free technologies, but help came from a surprising place. Like Reagan, Margaret Thatcher didn't believe in industry regulation. She was Britain's first female leader, but she'd trained as a chemist and was more proud of being the country's first scientist Prime Minister.
She was a woman among men, and she was a scientist among non-scientists. She regarded herself as Prime Minister as the sort of voice of science. She did go further than most politicians, but she was really bringing in the scientific dimension to politics in a way that nobody else ever did.
She absolutely understood the importance of stratospheric ozone depletion, and to be honest, I was incredibly impressed by her intelligence and the penetrating questions that she asked. And they were penetrating.
Just as the Montreal Protocol needed international support, Maggie stepped up. She appealed to world leaders to pledge vital funds.
Every country will be affected, and no one can opt out. Each country has to contribute, and those countries who are industrialized must contribute more to help those who are not. As we travel through space, as we pass one dead planet after another, we look back on our Earth, a speck of life in an infinite void. It is life itself, incomparably precious, that distinguishes us from the other planets. It is life itself that we must battle to preserve.
It worked. The developing nations soon joined the Montreal Protocol. The end of the global CFC industry, something Sherry and Mario had first appealed for in 1974, was finally a reality.
Mario Molina är 10 år yngre. Han härstammar från Mexiko.
And in 1995, Sherry, Mario and their colleague Paul Crutzen won the Nobel Prize in Chemistry for their work on CFCs and the ozone layer. Thanks to their early warning, 40 years later, the ozone layer is now showing signs of healing.
What we're seeing at this moment in time is the concentration of ozone-depleting chemicals is decreasing quite rapidly, showing the regulations are working. The ozone layer itself is no longer depleting, and there are now indications that the Antarctic ozone hole is showing signs of recovery.
Someone sent us this from England. Sherry with a gun shooting a spray can with his wonderful sideburns and his wonderful eyebrows. Oh, this was Sherry Rowland's study. If Sherry Rowland were here, you could not walk in because it would be piled with papers everywhere. He didn't see his desktop for years. There's the Nobel Prize itself, in the flesh. There it is. I'm proud of him as a person. His work, yes, but as a person, he was really great. He died in 2012, May 10th, 2012.
At the 20th anniversary celebrations of the Montreal Protocol, Sherry and Mario were the guests of honor.
At one point, they asked Sherry and Mario just to come on stage, and Sherry and Mario were introduced, and the whole audience stood and applauded. All of me. They applauded the two of them, and that was so moving. They said thank you. And Sherry and Mario looked. They were so astonished, but it was a wonderful moment.
If it can be done for protection of the ozone layer, surely it can be done for protection of the climate, the oceans, the ecosystems, and species. Let's bring back President Reagan and Margaret Thatcher. You've got to have leaders who can come to a conclusion and lead.
What we're talking about here is the precautionary principle, and that is, at what point do you take action as a caution against what might happen? By the time you get absolute certainty, it is in many cases too late to deal with the problem.
With climate change, that's a crucial message. We have a totally unacceptable risk. It would be so irrational to ignore this. And we can actually deal with it if we do it in a positive way.
We want to play our Freon Serenade. Come on, girls. 1, 2, 3. Marvelous.